Okay, Math 30-2 Polynomial and Sinusoidal Functions, Lesson number 8 Practice Test. Again, these videos are for study purposes only. I try my best to minimize my mistakes, but it will happen. I try to show and explain most of my steps. These videos might be long, but hopefully they will be helpful. Alright, let's get started. Which of the following is not possible for the graph of a polynomial function of degree 3? So degree 3 function either looks like this, where there is no turning points, so 0 turning points, and then 0 point of inflection, where it looks like this, where there are 2 turning points and 1 point of inflection. So those are the only 2 options. So they cannot only have 1 turning point, and they cannot have more than 1 point of inflection. So 1 is going to be B because they cannot have more than 1 turning point. 2. The end behavior of a graph of a polynomial function is such that the left tail is down in quadrant 3 and the right tail is down in quadrant 4. Okay, so this means that the graph is either going to look like this or they're going to look like this. Okay, it have to be an even degree, because the behavior of the both sides are the same. So it cross off 1 and 3 right away. And if it is a linear function, then that means it's a constant function. That means the graph is just a straight line. It cannot be anything else. So the only option is degree 2. Numerical response 1. The graph of the 4 cubic polynomial functions are shown. Okay, so write some. So this one, your leading coefficient is negative, and your y-intercept is positive. So that means your right-hand side behavior is down, and coefficient is positive. So right-hand side behavior down, and your y-intercept is positive. So this is 4. Just give me a second. Just let me check my answers. Yep. Leading coefficient is positive. That means the right-hand side goes up, and the y-intercept is positive. So let me graph 1. Leading coefficient is negative. That means the left-hand side, the right-hand side goes down, and the y-intercept is negative. So right-hand side goes down, y-intercept is negative. It's going to be 3. And last one, leading coefficient is positive, and y-intercept is negative. Positive means the right-hand side goes up. Negative means the y-intercept is negative. 4, 1, 3, 2. 3. The graph of this function has, so this is a degree 1 times this is x squared, so this is degree 3. And the leading coefficient is negative. And what is my y-intercept? Negative times negative 3 times 1 squared, which is equal to positive 3. So the y-intercept is going to be positive. And how many x-intercept does it have? Well, it has 1 x-intercept at x is equal to 3. And then this one is an x-intercept at x is equal to negative 1. So they say they have 2 roots at x equal to negative 1, but what it actually going to look like is it's going to look like something like this. So it barely touches x equal to negative 1, and then goes down to x is equal to 3. So we have 2 distinct x-intercepts. How do I know it's 2? Because you said this is equal to 0. When you have things, a factored form can equal to 0, that means x minus 3 is equal to 0, or x plus 1 is equal to 0. So you have a bunch of things multiplied together, and it is equal to 0. That means each of the individual items could be zeros. 4. Which of the following rows includes 2 functions that have the similar end behavior? So similar end behavior that must have must both be even degrees or both be odd degrees. And they must also have the same same sign of leading coefficient, right? So this one's positive, one's negative, doesn't check out. This one's positive, one's negative, doesn't check out. This one is a degree 2. This one is a degree 3. Doesn't check out. This one is a degree 1. This is a degree 3. So both of them are odd. And both of them, the leading coefficient is positive. So this is positive 7. This is positive 1. So 4 is D. 5. The polynomial function shown in this diagram can be written in the form of. So this is x is equal to negative 2. So that means x plus 2 is equal to 0. And then this is x is equal to 4. So x minus 4 is equal to 0. And because it barely touches, that means it has 2 roots at this location. So I will have a times x plus 2 times x minus 4 squared is equal to polynomial of x. So a is times x plus 2 times x minus 4 squared. 5 is C. Okay. Roger, Andy, and Serena were investigating the graphs of polynomial functions. After graphing some functions on his calculator, Roger made 4 conjectures about the graphs of these polynomial functions. Okay, graph. Okay, so conjecture 1, 2, 3, 4. So 6, Andy was asked to draw graphs which that can be satisfied the condition of these conjectures. All conjecture for which can be done is. So conjecture 1 is fine because you can just say y is equal to 2. So here's my x-axis. Y is equal to 2 will just be on top. That's fine. Polynomial function of degree 1 has 1 intercept. That's good. Yeah, so just typical 1. So 2 conjecture 2 is good. Degree 2 have 2 x-intercepts. Good. Degree 3 have 3 x-intercepts. Also good. So 6, all of them are correct. Serena was asked to draw graphs that provided counterexamples to these conjunctures. All of these can be done are. So for conjuncture 1, I will just draw it on the x-axis. Then it can. Then that works. Graph of polynomial degree 1 has 1 intercept. Degree 1 always have to have 1 x-intercept regardless of how you draw it, because degree 1 means there has to be a y-intercept somewhere. So 2 cannot be done. 3, if you want something that have 2 x-intercepts or not 2, so you can either touch it, draw it like that, or you can just draw it above it where it doesn't touch. So 3 can be done. 4, so we can draw it like this, you can draw it like this. Many different ways to do it. 4 can be done. So it's 1, 3, and 4. Okay, 8. Which of the following graphs are polynomial function? This whole thing, if a is less than 0, so if a is less than 0, that means there is 2 roots on the positive side. So touch. So this is touch the x-axis or downward up on positive side. So on positive. And then xb is greater than 0. So that means it is crossing, either cross this way or cross this way on negative x. On negative x. Okay? And then what degree is this? So C is less than 0. That means my right-hand side behavior will go down. So right away, I can get rid of B. And what degree is this? This is x squared plus x squared times x, so degree 3. And right away, you can also get rid of C. So which one of these touches it on the x-axis or just touches the x-axis on the positive side? This one. And this one touches on the other way. So 8 is A. So how do I know this? Well, since A is less than 0, we can just say A is equal to negative 5 or something. We have x minus 5 squared is equal to 0. That means x is equal to 5. And because there's 2 roots here, that means it will barely touch the x-axis at 5. I just don't know if it touches on the upside or downside. So it's A. Keep going. A projectile is launched in the air, blah blah. Height of the projectile above the ground can be modeled by this function. h represents a height in meters t seconds after it launched. To determine the height of the launch site, so if you're launching something, it usually looks something like this. So what is the height of the launch site? Well, that is a y-intercept, in this case the h-intercept. So 9 is going to be B. Okay, what is the maximum height above the ground reached by the projectile to the nearest tenth of meter? We're going to graph this. Okay, y is equal to negative 4.9 x squared plus 41x plus 8.2 plus 41x plus 8.2. Disable plot 1, zoom 6 it. You guys find my maximum, second calc, 4 for maximum. Even though if I can't see it, I can still find the maximum. Uh, 93.96. So 93.965, right? Round to one decimal place, 94.0. Make sure that 94.0 and 94 are not the same thing, because they ask you to round to the nearest tenth, you round to the nearest tenth. A metal rod is heated. The length of the rod, L millimeters, is measured at various temperature T. Due to experimental error, the data does not support a perfect linear relationship. So I want to do linear regression, like they told me, and I want to find the slope. So they want to find ax plus b, so the a value. Usually you write as mx plus b, but they only care about a. Okay, so let's graph this. Stat edit. Okay, so 20, oops. $32, $40, $54, $60, $69. 101, 105, 109, 113, 115, and 119. Okay, I'll just get rid of this graph, then zoom stat it, see what it looks like. Oh, I forgot to enable plot 1. Zoom stat 9. Okay, so linear regression, stat calc. Linear regression 4. List 1, list 2 stores the equation in y1. And again, if you need to do this on a different calculator or an older calculator, make sure to type in list 1, list 2, list 1, comma, list 2, comma, y1. Calculate. Okay, perfect. What is my slope? Slope is my a value, 0.36. 10 is a. Okay, using a linear regression, what is the expected length at temperature 84 degrees? So that means my x value is equal to 84. What is my y value? So, I have to go trace. X is equal to 84. Okay, my window is not big enough. Let's include my x. Let's increase my x maximum to 90. Graph it again. Trace 80. Oops. Trace down arrow 84. Enter 124.08. So 124. 11 is B. 12, or numerical response 3. The following values are taken from a graph from a third degree polynomial function. So cube regression, pretty easy question. Okay, stat edit, clear everything. -2. I'll just clear this one too. Okay, -2. Oops, negative. Oh, the type is subtract to -2. -1. Oops. And 0, 1, 2. Okay, 0, negative 18, negative 12, 0, 0. Stat, calc, cubic regression 6, and I only need one answer, so I don't have to store this anywhere. Negative 3. But what is the value of C? So value of C is 12. See here, C is 12. 12. Which of the following function is a periodic function? So periodic means it repeats like this. Well, it doesn't really exactly repeat. So the only one that is repeats is sinusoidal function. Which two types of function have similar end behavior? So any odd function have the same end behavior, and any even function have end behavior. So this is odd, good. Even and odd and even doesn't work. Even and odd doesn't work, and this is odd and repeating function. It doesn't have an end behavior, so the answer is B. Keep going. The graph shown here, A times sine B times T plus C plus D. What is my B value? Well, my B value is, I'm kind of, so my B is my horizontal stretch factor. And what do I need to know to find a B value? Well, so a new period is equal to I think B over 2 pi, or is it 2 pi over B? Alright, I'm a bit rusty on this. Forgive me. I will have to graph it, see what this looks like. So sine of B times T to the power of C. So on the test you're not too sure, just graph it and make sure your calculator is in radians. So I'm thinking that what is one period? One period for this is from 4 to 14. So one period is 10. So if I zoom 6 it should be exactly one period, right? So I'm thinking that it is 2 pi over. No, it's not 2 pi over 5, it's pi over 5. Okay, so sine of pi over 5x. So sine of pi over 5 times x. Okay, look, one cycle is exactly 10, so that checks out. So we know this C. How do I get a B value again? Well, the period, which is equal to 10, it is equal to 2 pi divided by B, pi over 5. Which is equal to 2 pi over 2 pi times 5 over pi, 5 over pi to 10. Okay, so what is this? Period is equal to 2 pi over B. Okay, that will be nice to remember if I'm writing the test. I just forgot because I haven't done this in a long time. Okay, use the following information to answer the next 3 questions. The partial graph of a sinusoidal function is represented on a calculator as shown below. The maximum and minimum values are integers. So my y value, the y maximum is so this is -12, this is 6, and each of these is 3. So -3, -6, -9, right? And x each so this is 2 pi, right? So 6.28, this is 2 pi, and then this is pi. And then each grid is pi over, so what is it? 1, 2, 3, 4, 5, 6. So if I do pi divided by 6, okay, 3.14 divided by 6, I should get the value. Yeah, 0.523. Okay, good. So each of these grid is equal to a pi over 6. Okay, what is the amplitude? Well, the amplitude, we can just draw the amplitude is maximum minus minimum divided by 2. So 3 minus -9 divided by 2, which is 12 divided by 2, so it's equal to 6. My amplitude is 6. What is my period? Well, the period looks like it goes from start to pi, right? How do I know it's pi? Well, each of these is 0.52. 0.52 times 6 is equal to 3.12, which is pretty much 3.14. So 15 is C, and period just from the top of from the start to a second top. 16, the equation of midline. Midline is the average between the maximum and minimum. So 3 plus -9 divided by 2. So -6 divided by 2 is equal to -3. So y is equal to -3. 16 is D. 17. The height of a student above ground on a circular Ferris wheel can be shown in this equation, where h of t is equal to 12 meters. Okay, so the diameter of the wheel is 12 meters. So this is 12. And the student started at bottom of the Ferris wheel, and the height is 3 meters above ground. So this is 3. Oops. So this height is equal to 3. So what is my D? My D value is my midline. So what is a midline? Well, the midline is the minimum height plus half of the diameter. So 3 plus half of the diameter is equal to 9. 17 is C. 18. Okay, here are the partial graphs of two sinusoidal functions as shown. So here is A. So graph A has the equation. Graph B can be obtained from the equation by changing some of the value A, B, and D. So A changes the amplitude, and we must change the amplitude A. B changes the period, and we're not really changing the period. So A, B, D. So we must change A. We cannot change B because that is a period. And D is a midline. So here is my midline of the second graph. Here is a midline of the first graph. So because the midline is moving, it must have changed. So the answer is A and D. And again, B cannot change because it is obvious that both graphs have the same period. Okay, if B changes, then the period will not have been the same. Okay, in a controlled laboratory experiment, the temperature give me a sec. Alright, let's keep going. Okay, in a controlled laboratory experiment, the temperature in a greenhouse is controlled by this electronic thermostat. C is the temperature in degrees Celsius. T is the time hour past midnight. Okay. So what is my period again? Period is equal to 2 pi over B. Okay, I'll just copy that down here. pretty big. So my period is equal to 2 pi over b. What is my b value? B is equal to pi over 3. So 2 pi divided by pi over 3. It is equal to 2 pi times 3 over pi. Cancels cancel. You get 3 over 2. Or sorry, 3 times 2 is 6. So that means every 6 hours there is a cycle. So that means my period is equal to 6. And how many 6-hour periods are in 24 hours? Well, 24 divided by 6 is 4, so 19 is C. Okay, what is the temperature at 2:30 p.m.? So they want us to substitute x is equal to 2:30 p.m. is 14.5 hours after midnight. So 12 plus 2 is 14, and then 30 minutes is half an hour. So 28. Oops. 28 plus 4 sine of pi times 14.5 divided by 3. 30 degrees. Again, I just substitute in x equal to 14.5 into this equation. Okay, the graph of a sinusoidal function is shown. What is a possible equation of the graph? Okay, so I know the period is equal to 2 pi over b. Therefore, b is equal to 2 pi over p. So what is my period? Well, my period is from 1 to half a k. Because if I go to k, there's 2 periods, right? So 2 pi over p. Well, my period is k over 2, so 2 pi over 2 pi over k over 2 is equal to k divided by 2 is equal to 2 pi times 2 over k, which is 4 pi over k. 4 pi over k, 20 is going to be A. So this is my b value, obviously. B is equal to 4 pi over k. 6. The graph of these functions are shown where a, b, c, d are whole numbers. No, sorry, a, b, d. There is no c. Okay, so what is my amplitude? Before my amplitude is 1. Now my amplitude, so my midline is 4. Now my amplitude is 1, 2, 3. So that means my a must equal to 3. Now, what is my midline? My midline is equal to 4, so that means my d value must equal to 4. And what is my period? My period went from 2 pi to pi. So my period went from 2 pi to pi, so b is equal to 2 pi divided by pi. So b is equal to 2. So 3, so what do I write down? 3, 2, 4. Okay, written response. The monthly average rainfall in the town is shown below, blah, blah, blah. Okay, the following method, sinusoidal function. Okay, so so it asks you explain how the value of a and d can be determined from the maximum and the minimum of the function. So d is my midline. So d is my average between the max and minimum, right? So d is equal to max plus min over 2. So that is the average, you add them. And then a is my amplitude. My amplitude is when you want how the difference and then divide by 2, so we can find out what's a this halfway point. So the half distance from the top to the middle and from the middle to the bottom is the same. So to find the difference, you go max minus min That is the total distance from the top to the bottom, and you'll divide by 2 to find the thing. The data in the chart can be modeled by this function, where it's an average rainfall in months T, with T is equal to 0 in November, and then T is equal to 11 in October. So this is 0, this is 11. If the period of function is 12 months, use a method to determine the exact values for A, B, and D, then find these things. Okay, so period is equal to 12. So B is equal to 2 pi over P, which is equal to 12. So B is equal to, divide top and bottom by 6. We get pi, or divide top and bottom by 2, we get pi over 6. Okay, we get B. And then A, what is a maximum? Now it looks like the maximum is 167. What is a minimum? Minimum is 36. So these won't be the best, but it's good enough. So 167 plus I don't know why they're adding. Oh, yeah, that's fine. 167 plus, what's my minimum? 36. Divided by 2 is equal to 101.5. This is my D value, and then 167 minus 36 divided by 2 is equal to 65.5. And this is my A value. So I just use the two formulas on top, and I found what's the maximum minimum in the graph are. According to a model in previous bullet, what is the average monthly rainfall in town to the nearest 0.1 millimeter in the month of February? So, plug all those in. A is equal to 65.5 times, 60 times sine of BT. B is pi over 6 times T. T is equal to, so T is equal to 0 is in November. What is T in January or February? 1, 2, 3. So T is equal to 3 times 3 plus pi over 2 bracket plus D. What is my D value? 101.5. Alright, let me just double check. 65.5. Oh, it is 101.5. Okay. I was looking at the wrong part of the answer sheet. Haha. Okay, a second sinusoidal model is determined performing the sinusoidal regression. Blah, blah, blah. Perform trig regression on this and round to 2 decimal places. Okay. So we are going to do the same thing, except this time we're going to use the sinusoidal regression. So let's go stat edit. Clear these. Clear these. Okay, let's see. 0, 1, 2, 3. Oops. No, there's no 12. Oops. And line 2 is 167, 154. Okay, stat calc. Let's clear this. Enable plot 1 and zoom 9 it. Okay, here's my sinusoidal graph. Stat calc. We want sine regression and iterations. I think it goes up to 15. My period, I can automatically change my period to 12. I want to store my regression in in y1. Calculate. Okay, so 64. So how many decimal places do you want again? Two decimal places. 64.52. Sine was b. 0.52. T plus c is 1.61. Plus d is 100.97. Okay, then they want to find the month of February, which means x is equal to 3. So trace x is equal to 3, enter 98.9 degrees. 98.9, not degrees, millimeters. And by this, I also meant millimeters. So there's a bit of difference because the calculator does a way better job than we do. And it looks to me like the maximum might not quite be at month 1, but it could be month 1, so we don't really know. Okay. Alright, that's it for polynomial and sinusoidal functions, lesson 8 practice test. Hope you learned something. Goodbye.